Okay, so I'm gonna start with an easier question first, and then we can do maybe two more, a little more complex, so you can see how it works with like the same setup. I read the question first so that when I am reading the problem, I don't get confused and overwhelmed with the information. Because what you'll notice, especially with the other HESI exams, that a lot of questions had a lot of fluff and numbers that you don't even need to put into the equation. So the question is, how many milliliters will you administer per dose? And so now that I have that, what I do is by this star, I go in and I put milliliters per dose because that is what the question is asking for. And then I'll go in and read the question. So the doctor writes an order for a liquid oral medication. The order says to administer 15 milligrams by mouth every 4 hours as needed for sore throat. Pharmacy dispenses you with 30 milligrams per 3 milliliters. So another reason I said to read the question first is because this is an example of information being in here that you don't need, which is the every 4 hours administration. You don't even need to pay attention to that. So the things that you do want to take from this is the order. So the order here is administer 5 milligrams by mouth. So I write the order down first, and then if you can see like in this little corner here, that's why I put this first. So before I even start trying to work out the problem, I always put order, available, rate, what else? Time, because some of them need time, the weight of the patient. So I list everything out that I'm going to need to solve the actual question here before I even start the problem. That way you don't forget anything in your equation. So I have the order and what's available because that's the only thing that this problem gives us. So the order is 15 milligrams, and then what's available is they dispense 30 milligrams per 3 milliliters. So I'm going to write that down next to available, 30 milligrams per 3 milliliters. All right, and so now we can go to working out the problem. So we're looking for milliliters per dose. So how I like to start my equations is by what I'm looking for, what the question is, what the question is asking. So milliliters per dose, I always put, I put milliliters at the top, then dose. And so how I start off is I start with whatever is at the top. So as you can see, I have milliliters at the top. So that's what I'm going to look for when it comes to my little information. So the reason I can't write right now. The reason I also do this before starting my equation is because I won't have to keep going back and forth looking at the problem as a whole. I have everything that I need right here, and then I do like a process of elimination with this box as well to make sure I use every single thing in this box that I needed. So I'll show you as I go. So milliliters at the top. So I'm going to start with milliliters. That way it's easier. So you see milliliters here. So I'm going to start with 3 milliliters. And the way you know what to put at the bottom is because you just basically finish off whatever it is that they gave you. So it's 3 milliliters per 30 milligrams, right? And then when you come over here, another important thing, whenever I am doing my dimensional analysis, I go in this direction. So I have milligrams here, which means that I'm going to need to have milligrams here. So remember I said I put everything in this little box so that I know what all I need for the equation. So I used this already. I already used this. The only thing left to use is the 15 milligrams. And then we're also looking at like the direction that our dimensional analysis is going. So milligrams, 15 milligrams. So it matches up because the only thing that's left over is milligrams. This just helps me remember that I use every single thing in the equation. So I have 15 milligrams over 1 dose because that was the order. So to make sure that you use everything that you need, you have to go in and cross it out. I do this even if you feel like you already know that you used everything, still do it just so you won't miss anything. So anything that has like, I call them like sisters. So milligram is 2 of those, so they have sisters. The only ones that are left out is dose and milliliters, and that is what lets you know that you have everything you need, because that's what you should be left with, because remember what we're looking for is milliliters per dose. So that's how you know if you are even on the right track before you start wasting your time trying to plug in numbers on a calculator and everything, because you know that you were only left over with these two things. We're going to plug these into the calculator and we get 45 over 30, because you multiply these two and then multiply these two, and we get 1.5 milliliters per dose. So then you look at your problem and then the correct answer is C. Okay, so here's a similar question so you can practice. So like I said, I start off with reading the question. How many milliliters will you draw up and administer per dose? That way I can finish off and I'll know what to start with. So milliliters per dose is what the question is asking. The doctor orders an IV bolus. The order says to administer IV now 12.5 milligrams. You are supplied with a vial that is labeled 50 milligrams per milliliter. Okay, so the order, we start with the order. We have an order for 12.5 milligrams. And then what's available is 50 milligrams per milliliter. You could put 1 per 1 milliliter just so that you at least have a digit there if you want. So per 1 milliliter. Another thing I also like to do, which is, this is optional, but sometimes if it's nothing else that I'm looking for other than a dose, next to order, I'll just put per dose. That way I know how to add it into my calculation. Okay, so we are looking for milliliters per dose. So that's how we're going to start off our calculation. Remember, because that way you know if you're leaving anything out or not. So remember, we are starting off with whatever is at the top, which here is milliliters. So look at what we have in our little box, and milliliters is here. So we're going to start off with 1 milliliter. That's why I put the 1 in the front. 1 milliliter over for every 50 milligrams. Okay, and then remember, we want to match up whatever we have here is what we want to match up with here. So we have milligrams. So if you put milligrams here, then you'll know what to look for on this side. So the only thing left is 12.5 milligrams per dose. So this is per every dose. And then we can go across and do our multiplication. Oh, and don't forget to, I'm moving a little fast, but don't forget to cross out everything to make sure you have everything. So we have our sisters out and we are only left with milliliters per dose. That's how you know we are on the right track with our equation. So it's going to be 12.5 over 50. And then we get 0.25 milliliters per dose. And so the answer is going to be here. It's going to be B. All right, so the next question has a little bit more information, but it's the same setup. So I left it blank so that you could kind of read through first if you want and kind of set it up yourself for practice. You can pause it too. So let's start with our question. So how many milliliters per hour will you administer? So that is what we're going to be looking for. Milliliters per hour over here. And then, okay, we can read. So the doctor orders an IV weight-based medication to be infused at 4 micrograms per kilogram per minute. The patient weighs 198 pounds. You are supplied with a bag of IV medication that reads 250 milligrams for every 250 milliliters. How many milliliters per hour will you administer? So let's see what we need. So the order, we put our order. You probably already wrote this. The order is for 4 micrograms per kilogram per minute. Okay. And then the weight. So this one is a little different from the other ones because we have a patient's weight. And the patient's weight is 198 pounds. And the last thing we have here, the order reads 250 milligrams per 250 milliliters. So that is what we have available. So we'll put that there. 250 milligrams per 250 milliliters. Whenever you see that something reads whatever, it's what you have available. All right, so let's start our setup to kind of see our practice for you. So we're looking for milliliters over hour. Remember, we are starting at the top. So this is the way that it keeps me to remember where to have a starting point. So I will always know my starting point because I know I'm starting with whatever I have at the top of what I'm looking for. So we're going to start with milliliters, right? So if we look over here inside of our little box. Okay, so milliliters is here. So we have 250 milliliters. And then we have for every 250 milligrams. Okay, and then remember we are going this way. So the only other thing, so we have milligrams. Okay, we already used these two. Make sure you cross them out so you know you won't reuse anything. So when we look back inside of the little blue box, the only thing we have not used that we could use for milligrams is 4 micrograms, but we're going to need to convert micrograms to milligrams here. So what I do is you want to put 1 milligram because we know that for every 1 milligram is 1,000 micrograms. So that's how you get micrograms into your equation so that you are able to use it from here out of the box. So going this way, use the same unit. So we have micrograms here and we look back in our box. Now we can use our 4 micrograms from the order. So 4 micrograms over, and then whenever it's set up, hopefully this makes sense, but whenever it's set up like this, where it has like a microgram per kilogram per minute or milligram per kilogram per hour or whatever, I just kind of I like to call it like I bounce from each bracket. So once I use the milligrams, then I know I'm going to use the minute just to make sure I use this entire order. So we have 4 milligrams per kilogram. And I usually put a 1 in the front. That way I know it's per each kilogram. Okay, so same thing. So we have kilograms. We want to put kilograms here. Okay, so this is where it is based on what you want to do. I feel like for me, it just gets complicated and takes up too much time to try to convert every single thing. Weight, I just convert myself in a calculator. So we already know. You can do the same thing we did here. Where is it? Here. With converting the milligrams to micrograms for this section. Or you can, if you already know how many kilograms it is, you could just skip that part and put it here so you won't have to make your thing unnecessarily long. So we know we have 198 pounds and we know that it's 2.2 pounds in each kilogram. So I just put in a calculator 198 divided by 2.2 and then I get 90 kilograms. So I put my 90 kilograms here to skip that. And remember, we just go from the kilograms now to minutes. So it's 90 kilograms for every minute. Put 1 minute. Okay, so the reason you know that we are not done with the equation yet is because we stopped at minutes, but they want us to have our answer in milliliters per hour. So we have one more step. Okay, we're going this way. So we have minutes there, which means we'll have minutes here. So we know for every 60 minutes is 1 hour. All right, so now we have our hour. So now we can calculate our equation. But just to make sure you always do your crossing out the sisters so that you make sure you end with the right numbers. So we have sisters for milligrams, micrograms, kilograms, and minutes, which leaves us with milliliters and hours, which is correct because that is what we are looking for. If you do it this way and you cross out and you are only left with the units that the question is asking for, then you won't have really second guess your answer, because I know on a HESI practice, there's no multiple choice. So you just kind of have to just know, and this is the way that to kind of give you that confirmation. So you plug everything into your calculator, go across the top, then across the bottom. You can pause this so you can see what you get, and we'll just see if we came up with the same thing. Okay, so we're going to multiply 250 times 1 times 4 times 90 times 60 at the top, and we end up with 5,400,000 And then for the bottom, we multiply 25 times 1,000 times 1 times 1 times 1. So we end up with 25,000. Okay. And then when you multiply those,